Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled Life Extinction, Planet X and Fukushima. Now, on March 11, 2011, a large earthquake and tsunami just off the coast of Japan led to the largest ever nuclear disaster on Earth. And it was at the Fukushima Daiichi nuclear power plant. And this power plant had 6 nuclear reactors. 3 were in operation and 3 were shut down and awaiting refueling. And the 3 operating reactors automatically shut down at the time of the earthquake, as was expected. But the tsunami then damaged the emergency generators designed to power cooling in case of a power failure. And since even shut down, the fuel rods in the reactors require circulation of cooling water, without the power, these overheated. This led to meltdowns in all 3 reactors and the release of radioactive compounds into the atmosphere and into the ground. And in addition, a pool containing spent fuel rods in the Reactor 4 building also overheated, thus leading to more releases. And we see here a picture of the Fukushima Daiichi nuclear power plant in Japan on March 11, 2011. And we see there an explosion. This seems to be due to the release of hydrogen, which occurs when overheating occurs inside the reactor. And this power plant uses boiling water nuclear reactors, and these were designed by General Motors. And these reactors produce heat from nuclear fission, and it's passed on to water, which runs steam turbines and then turns electrical generators to generate electricity. And because of the need for water to cool the reactors, the spent rods, and also is used as a moderator, and a moderator is a material used to slow down neutrons and thus maintain controlled fission. And these power plants are usually built near coastlines. So they are vulnerable to tsunamis, as was the case here. Now, it was already known in 1975 that the containment vessels used in these nuclear reactors were not strong enough and could tear in the case of coolant loss, which could lead to uncontrolled release of radiation. And in fact, in 1976, 3 scientists resigned from General Motors as a result of this design issue. They were not safe, but they continued to use them until this happened in 2011. And this is an image, a diagram of the reactors. It's made up of a steel vessel. It's under pressure, I think to 75 atmospheres. And it contains fuel rod assemblies that are placed inside the reactor. And it contains these control rods. These control rods are neutron absorbers. And when placed in position, they stop the reaction. If they are inserted partially, they just slow it down. But these are the control rods that must have been inserted when the reactors were shut down at the time of the earthquake. Now, and as you can see, there's water. Water comes in, goes into the reactor, acts as a coolant and moderator, and it goes out, it creates steam, and from there it generates electricity. Now, the fuel used in the reactor was enriched uranium, except for Reactor 3, which had a mixture of enriched uranium and plutonium. And the fuel rods, these fuel rods are 13 feet long, and they contain pellets made out of uranium, except for the ones in Reactor 3 that had plutonium in them. And now natural uranium contains about 0.7% uranium-235. And uranium-235 is the isotope which leads to the most energy or heat release due to the fission. The rest of the uranium is uranium-238. However, the uranium in fuel rods is usually enriched with uranium-235, so that they contain 3 to 5% uranium-235. Then during the nuclear reactions inside the reactor, some of the uranium-238 gets converted to plutonium-239, which then fissions as well, thus also providing some of the heat. It provides about a third of the heat released due to the fission reactions. Then 85% of the reactions lead to fission into lighter nuclei and several neutrons. And the lighter nuclei are usually krypton and barium, but it can lead to other ones. And about 15% leads to the release of gamma rays. 15% of the fission reactions. Sorry, not the nuclear capture reactions, because this is what happens. Neutrons always start the initial reaction. They are captured. So uranium-235 becomes uranium-236. It still has 92 protons, but it gains 1 neutron. The number of protons tell us that it's still uranium, but it's now slightly heavy. It contains 1 more neutron. Then uranium-236 fissions, or some of it fissions, about 85% fissions into lighter fragments. And these fragments interact with atoms in the environment and ionizes them, which means they get turned into positive ions and free electrons. And these then recombine into neutral atoms, which leads to the release of heat. Now the problem is that plutonium is extremely dangerous, because only tiny amounts, if it gets inside a human body, for example, if it gets into a person's lungs, that person is extremely likely to get lung cancer. And the Fukushima disaster released, and it continues to release, it is not contained, into the environment radioactive isotopes. And these isotopes are different forms of a certain natural atom with different numbers of neutrons in the nucleus. Some of these isotopes are extremely long-lived. For example, neodymium-144 has a half-life of 2.3 times 10 to the 15 years. That's 2.3 quadrillion years. And this means that it will never be gone. And as long as it is around, it will continue to decay. And it decays into cerium-140, which is stable, and therefore ends the process. But the decay process from neodymium-144 to cerium-140 is alpha decay. And this involves the release of an alpha particle, which is a helium nucleus. And also to the release of gamma radiation. Now, the helium nucleus is not very damaging as long as it is outside the body. As it can be shielded by a piece of paper, because it's very heavy and it's positively charged, so it reacts easily with any material it encounters. So if outside the body, it does not actually penetrate very far into the skin, so it's not a real problem. The problem is when it is deposited in the body or when it's ingested. And when it does that, it repeatedly bombards nearby tissue, leading to mutations and destruction of cells. And that, in that way, because it's so heavy, it's extremely damaging to that tissue it has been deposited in. And plutonium-239 is an alpha radiation emitter. In other words, it also emits helium nuclei. But it is extremely hazardous if ingested, because it's a very strong carcinogen. And only a tiny amount, say about 30 micrograms, which is 1/1,000,000th of an ounce, when it enters a person's lung, that person is almost certain to get lung cancer. And on top of that, it seems to be absorbed mainly into soft tissues once it enters the body. So it has a tendency to go to places like the liver or the bone marrow, which are extremely susceptible to this kind of radiation. And also, we cannot live without our liver or our bone marrow. So it often leads to cancer and death. Now, gamma rays are also released when radioactive isotopes decay, and gamma rays are very difficult to shield against because they are photons, they have no charge, and they therefore do not react easily with material they encounter. They are extremely damaging to living organisms, and they do not have to be inside the body because they can easily penetrate through the skin into the interior of the body. And gamma radiation is also ionizing, that is, it knocks electrons out of atoms, which means they become ions and we have free electrons. And this causes what's called oxidation, the breaking of molecular bonds, and ultimately the destruction of cells' DNA, and therefore the destruction of cells. And when large number of cells die, we can get organ failure and death may result. And then another possible outcome is mutations in the cell's DNA, which may lead to cancer and ultimately death. And here we see a rabbit which was born without ears, and this rabbit was found in the Fukushima region after the nuclear disaster, which demonstrates the fact that the released radiation is leading to genetic mutations. Now, other isotopes are also released. Some of them do not have such extremely long half-lives, but they are also extremely damaging. For example, iodine-131 has a half-life of only 8 days. But this does not mean that it is gone in 8 days, only that the amount present in the environment halves in 8 days. But because we have ongoing release happening from Fukushima, this compound continues to spread and accumulate in the environment. And exposure to iodine-131 leads to thyroid cancer. Then another compound with a reasonably long half-life is cesium-137, which has a half-life of 30 years. And this compound will therefore spread around the world and continue to release gamma radiation as it decays. Cesium-137 causes genetic mutations in both humans and animals. So eating food contaminated with this radioactive element can lead to cancer and or deformities in developing babies. And at the moment, there is no known way to stop the release of alpha, beta, and gamma radiation as a result of decaying radioactive isotopes. The beta radiation is the release of a high-energy electron, and when a neutron decays into a proton and an electron. Beta decay can be quite damaging to living tissue, but not nearly as damaging as gamma radiation or as alpha radiation inside the body. Now, after the Chernobyl accident, which happened on April 26, 1986, everyone should have known better than to continue to build nuclear power plants. In fact, that they should have known better before they even started. But because the dangers were known before then, it was well known that before any nuclear reactor was built, that if something went wrong and radioactive isotopes were released, that the effects could not be reversed. The Chernobyl disaster was not actually nearly as bad as the Fukushima disaster. as after the initial meltdown, it was possible to build a concrete barrier around the Chernobyl reactor, which contained the radiation. However, Fukushima is not contained. It continues to release radioactive compounds into the atmosphere, into groundwater, and into the ocean. Now, this shows that there has been an increasing trend in cancer-related deaths since the 1950s. And this is likely to be connected to the radioactive compounds released into the environment due to nuclear weapons testing, which started around that time. But the release of radiation into the environment actually started, with this nuclear weapons testing, was not as bad or nearly as bad as what was released by Fukushima. And this is according to a report from 2013, which stated that the release from Fukushima up to that time had been 100,000 times greater in terms of the cesium-137 that it released than either Chernobyl or the nuclear weapons testing. And so the release of radioactivity, as I said before, was likely, that started with nuclear weapons testing, was likely to be the most important factor in the steady climbing rate of cancer deaths since the 1950s. And of course, the 1950s was when nuclear weapons testing fallout started. And here we actually see a diagram that explains the amount of radiation. The yellow is the amount of radiation in terms of cesium-137 that was released during nuclear weapons testing. The orange is what was released by Chernobyl in 1986. And this is weapons testing by the 1960s. And this is Fukushima. Oh, okay, I said in November, but it's actually only the release measured from March to July 2011. And this was 100,000 times greater. As you can see, the top here, it's about 1,000. The top here, and this is in becquerels per cubic meter, is 100 million. So this is 100,000 times greater than this level here of 1,000. And it does vary from 100,000 to 100 million, the Fukushima release. And this was only from March to July 2011, just a few months. And you can imagine what has happened since then, because it has continued. There is continuous release of radioactive water into the Pacific Ocean, and there is continuous release of radioactive water into the ground below the reactors. They talked about an ice water barrier, but it is known now that it failed. Water is going into the groundwater in Japan and contaminating everything. Now, when radioactive compounds are released into the ocean, they are very quickly taken up by the smallest organisms like algae, plankton, the bottom feeders. And so the water is quickly cleared of most of the radiation, but it is then stored in the organisms at the bottom of the food chain. And thus, the radioactivity accumulates in these organisms, and this is called bioaccumulation. But then we get what's called biomagnification, because these organisms are eaten by other organisms, which are eaten by other organisms. And at each step in the food chain, the amount of radioactivity is compounded, in other words, biomagnified. So this is how it goes. If we measure the radioactivity in ocean water soon after the release, it may be quite low. But the radioactivity of algae, plankton in that water may be 2,000 times higher. Then if you measure the radioactivity of birds eating the plankton, that may be 40,000 times higher. And if you measure that of birds eating insects which feed on the plankton, it may be, say, 500 times higher. And then if you measure the concentration in egg yolks in the eggs laid by these birds, it may be 1,000,000 times higher. And since human beings are at the very top of the food chain, human beings will receive, of course, the highest dose. Now you see here, these are plankton, these are organisms which live in the Earth's large bodies of water. They cannot swim against the current. Some are microscopic in size, such as bacteria and algae, but others are larger, like jellyfish. And certain large aquatic organisms are dependent on the plankton as it is their food supply, for example, some whales. But plankton is also the bottom of the food chain for most of the fish in the oceans. And research has shown that the release of radioactive compounds leads to impaired growth and reproduction in marine life. And this can lead to massive die-offs as a result, because the death of organisms at the bottom of the food chain leads to animals higher up on the food chain starving to death. And it's probably for this reason that the Pacific Ocean has been reported to be a dead ocean. And this has been reported by the Scottish yachtsman Ivan McFadden. And he sailed the Pacific Ocean before and after the Fukushima nuclear disaster. And he said that it was teeming with life before, but after, there was no fish, no birds, just silence, to the point that it haunted him. And here we see 10,000, part of the 10,000 of dead sea lions that washed up in California in December of 2014. Massive die-offs are happening. And have been happening since 2011, actually. Now, the problem got so bad with sardines that sardine fishing was banned in 2015 for the first time in 30 years due to the fishing population having collapsed. And part of the ocean, 150 miles off the coast of California, that had before the disaster been covered in, less than 1% of it had been covered in dead marine life, was 2 years later, in 2013, 98% covered in dead marine life. And this shows you how this disaster has destroyed the life that the organisms that were alive in the Pacific Ocean. So this has killed almost everything in that ocean. So it's no wonder it's reported to be a dead ocean. Now, massive die-offs have also been reported along the west coast of the United States. Tidal pools are now empty of life. Dead starfish are often found. Dead otters wash up on shore. And no clams are often found when they should be found, and where. Now, one naturalist has reported that she felt like she was doing nothing but counting dead animals. And here we see huge amounts of dead jellyfish on Baja, California in 2015. So the Pacific Ocean appears to have died due to the Fukushima disaster, but this will not end there, because the release of radiation into the atmosphere and the ocean continues, and therefore it will eventually spread to all land masses and all oceans. So it seems that the planet is in the midst of an extinction level event as a result of this disaster. Note too that 50% of the planet's oxygen supplied is supplied by algae and phytoplankton, and the world's phytoplankton has dropped by 40% since 1950. Also, we see that oxygen supplies worldwide have dropped from 21% to 19%. And the reason for this seems to be due to the fact that low-dose radiation causes global oxygen depletion through the killing of all oxygen-producing life forms, as these life forms seem to be particularly sensitive to radioactive contamination. Now we see here an image of phytoplankton, and these are microscopic photosynthesizing organisms or plants which inhabit most of the Earth's bodies of water. And they are the basis of the marine food chain. They also produce 50% of the planet's oxygen supply. So when they are gone, the marine food chain will be broken and all the oceans will be dead. And the planet will be running out of oxygen. And this oxygen, I'd like to add, also leads to the production of ozone. So this is another way that all life on Earth will be killed, because ozone protects us from high energy ultraviolet light, and without it all life on Earth will die too. So radioactive contamination is extremely long-lived and irreversible, and it is leading to the extinction of all life on Earth. As humans are on the top of the food chain, we cannot avoid this contamination and its long-term effects in terms of cancer and reproductive problems. The extinction process started with nuclear weapons testing, but ever since Fukushima, it has accelerated at an extreme pace, and it's likely that in 20 to 30 years there will be just about no life left on this planet. As a result, Earth is therefore becoming a desert planet, much like Mars. However, Scott and I have been showing for many months that the solar system has been invaded by Planet X objects or stellar cores, and that these objects are affecting the Earth and the Sun, and all leading to a great increase in seismic activity, which, by the way, is very often underreported, just about always, and often not reported at all. And the way we know this is because local reporting agencies often report a huge amount of these earthquakes, which never show up on the USGS maps. So it's likely this kind of seismic activity is likely to further accelerate this extinction event. And the reason for that is because we are likely to have tsunamis, and since there are nuclear power stations on every continent and usually close to the oceans because they require large quantities of water, it is of course inevitable that a tsunami and a repeat of what happened in Japan repeats itself over and over, thus accelerating the speed with which the extinction of all life will be reached. In conclusion, the Fukushima disaster was an extinction-level event, which is likely to lead to the end of life on Earth in 20 to 30 years. However, because of the presence of the Planet X objects, which are rejuvenating and increasing in number, and are negatively impacting planet Earth, mainly through increased seismic activity, and since there are so many nuclear power stations worldwide, this extinction event is set to accelerate its pace in the very near future. Now, I'd like to point out that the Planet X objects by themselves would not do this if there was no use of fission technology on Earth, and there was no weapons testing either. So, what can we do about it? We need to realize who is really responsible for the state of affairs, and the one responsible is a former archangel called Lucifer, who rebelled against the creator of all. He is the prince of the power of the air, and he places thoughts in human beings' minds and has driven them to use fission technology and into using nuclear weapons, which is meant to lead to life extinction on this planet. He is the one who causes war and has done what we see happening on our planet before. There is evidence that nuclear weapons were used on both Mars and on Earth in ancient times. He has used war to destroy countless civilizations, which is why the solar system is full of ruined cities and wrecks of countless spaceships. It is likely that he has done the same thing across the galaxy. The angelic beings who pretend to be aliens work for Lucifer and have the same aim as he does, to destroy all life on this planet. They have from ancient times worked to teach mankind what is evil and what will lead to our destruction. Our only hope is our Creator and Savior, Jesus Christ. We need to turn Him, ask Him to forgive us, and hand the course of our lives to Him. If we do not do this, Lucifer will continue to use us as a conduit to do what he plans to do on this planet, which is to destroy it completely. Remember that Jesus said, I am the way, the truth, and the life. Standing for the truth is standing for and with Him. He is the source of eternal life, the abundant, joyful, and peaceable life that goes on forever and ever. We need Him. Now, these are my references if anyone is interested. And this is Dr. Claudia Albers, Planet X physicist. Thank you for watching.
What's a super easy way to tell that your bed is awful? The raw egg test. Let me prove it.
Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled Huge Planet X Objects in Stereo Images. Now Planet X objects, or stellar cores as I like to call them, are old stars which have invaded the sun and come into the sun's corona to absorb energy and plasma from the sun. And thus they rejuvenate so that eventually they are able to emit light once again. In addition, rejuvenated stellar cores seem to regain the ability to have plasma, loop, and jet-like plasma ejections, and that is once they are rejuvenated. Now, large Planet X objects or stellar cores appear in many stereo HI1, which are visible images, which many people believe are lens flares and or images of the sun. So in this article I analyze these images and show that they are neither lens flares nor are they images of the sun. The left HI1b image, which we see here, shows a large spherical object which seems to be transparent. And the reason why it seems to be transparent is that there is another circular outline behind it, which we can see here. Now, in the right image, we can see actually what there is one object that was obviously in the image. So this is actually an image from 40 minutes before this one. Both are from March 25th, 2008. And we can see that this bright object was in the image, but it was hidden. But what we do see is what these circular outlines are. And they seem to be these large spherical objects, or at least they are, at least one of them is seen here. The other one, there is a very faint dark outline there that shows its presence. And I believe what happens is these circles are added to highlight their presence in the images. Obviously, the people who are studying these objects want to know where they are, and these circles are added so that their positions are known. Then what we have is another object which appears in front. As you can see, this circular outline is superimposed on this image, but we can see here what it is. There is obviously an edge between the upper portion and the lower portion, and we see there's an object there, and it is emitting very little light, which is why it's so dark. And then there is this object where we can see the top of this object, which must have been in this image but only became visible when something happened to the image that made it visible. So obviously these objects are being hidden. There's possibly another smaller one there. Now, it does seem that the presence of apparently transparent spheres or circular outlines in these images indicates the presence and position of large Planet X objects or stellar cores in the sun's corona. And we see another HI1b image. This one is from March 17, 2008 at 2249. And the large Planet X object, which could be partially seen in the right image in figure 1, makes its appearance once again. So we can see this object does not seem to be spherical, but slightly oblong or somewhat lemon-shaped. And as we can see, this is usually because another object that is more lemon-shaped usually appears just behind it. Now, its surface is dappled, that is covered in small rounded patches, which suggests it has liquid, hot, boiling plasma on its surface. So it's got to be a star, one of these rejuvenated stellar cores. So the object in figure 2 and in figure 3 seems to be covered in surface plasma and also seems to be emitting more light from its right side than its left side. As you can see, there's this triangular shaped area here that is much darker than the rest of the image. And this is of course a sign of a rejuvenating stellar core. The object cannot be a lens flare because a lens flare has to be a secondary image of a real object, and there is no primary image of this real object in this image. In other words, for this object to be a lens flare, there would have to be two images of the same object in this HI1b image. And the brighter one would be the primary image, whilst the dimmer one would be the secondary or lens flare image. Now in figure 3, we again see a few stellar cores. There are actually three. We see the bright one. We see that it has a triangular dark shape on the side. That dark shape is always facing towards the sun, which is on the left here. So that's the brightest object there, and because of that triangular shape, I actually give it a name. I call it the dark triangle stellar core. And we can see that there is an outline behind it, and that seems to be another slightly larger stellar core that is more oblong, and I will call this one the lemon stellar core. And then we also have this circular outline again, we can see here, which indicates there's this outline, and then there's this outline here. So at least this outline indicates the presence of another or one of these darker stellar cores that have not rejuvenated as much as these brighter ones. So there are at least three there. And in addition, we still have a faint, very large outline at the edge of this image. We can see it on the upper left and the lower right, and this may indicate a very large object in the background, possibly another stellar core, but it's not as clear in this image as in other ones we will see. So I will call this one the dark triangle stellar core, just to differentiate them. And here again we see the dark triangle stellar core. As you can see, this area on the stellar core is much darker, and there is this large circle behind it, which is also dark on the side where the sun is. And then there is the smaller one, which seems to have a large plasma ejection to the upper right. So this one seems to be very energetic because of this large plasma ejection it seems to be having. So I will call it the energetic stellar core. It is much smaller than the other ones. Now, the large circular outline behind the dark triangle stellar core, this one, seems to be larger and a darker stellar core, and therefore still possibly some way from being completely rejuvenated. But even this one, I don't think it's completely rejuvenated. It's possibly exchanging plasma and absorbing energy from the sun. That's why we see this dark region on it. And so this circular outline appearing behind indicates the position of another smaller stellar core. We do see the circle there, which usually indicates the presence of a darker stellar core, and the position of these objects is probably determined through the use of another detector, probably the stereo A, so that because it's not possible to actually see them through the other stellar cores. But these are added to the image so that whoever is studying them knows where they are. And now the fact that the smaller stellar core seems to be having a plasma indicates that it is rejuvenated and has hot boiling plasma on its surface. It can have this huge ejection. It's huge compared with its size. So there are three front stellar cores which are aligned with each other. In other words, they are in a straight line with respect to the detector. And this suggests that they are very close to each other and magnetically connected to each other. They also have to be very close to the sun in order to consistently appear aligned in this manner. If they were further from the sun, they would appear to at times they wouldn't be aligned in this way. They have to be very close to the sun because the detector is facing basically the sun, or just to the right of the sun in this. So they have to be very close and just to the right of the sun in order to appear to be aligned in this way. Now notice the largest bright sphere appears to be almost transparent, as you can see here. And why it appears to be transparent is once again because the presence of these circles, which indicates the presence or the position of the darkest stellar cores. So the fact that these apparently transparent circles, which are found in many Hi1b and A images, indicate the presence of large stellar cores, means that we will be able to identify where these are in many of these images. So because now we know what this means, the presence of these circles means that there are stellar cores in the image. And these stellar cores are huge. So I will call this one L1 stellar core, where L stands for large. There may be other large ones, so we'll stick with just L1. Now, the very large stellar core seems to be dark on the left side and on the right. And the darkest side faces the sun and is likely to be a sign that the object is still absorbing energy from the sun. And the 2007 stellar core also exhibited the same phenomena. It emitted light from its ionizing envelope far from the sun, as you can see here. It's emitting light from its ionizing envelope, or this ionizing envelope that envelops the star. And when it was still far from the sun, it emitted light from that envelope on the side facing away from the sun. And then as it approached the sun, as it moved closer to the sun, it became darker and darker. So not only did it emit light from the side facing away from the sun, it actually became darker as it approached the sun. As you can see here, as it gets closer, it's almost completely dark. So this shows that there is this transfer of energy, that these objects absorb energy in the form of light from the sun, and that they move from a light emission mode when they are further away and facing away from the sun to an energy absorption mode when they approach the sun.
AI and deep learning are growing like crazy. You should take online deep learning courses on Udemy. They've got fresh new courses, all taught by expert instructors.
Approach the sun. Now we see here another Hi1b image against visible light from March 22nd, 2008. In this image we see 4 stellar cores. And the first one is the dark triangle stellar core, which is in the forefront. Then we see the lemon stellar core behind it. We see again the dark stellar core behind it, indicated by the circle. And then we see the other one indicated by the other circle behind it. So again, we have 4. And the brighter ones are likely to be more rejuvenated than the others. What else do we see? We see that this dark triangle feature on the object seems to have moved or rotated towards the left. And this means that these objects rotate and possibly rotate along, in a plane that's close to the ecliptic. Maybe an indication of that. But then we see in this image again aligned stellar cores. There's this a dark one in front, and then there's the smaller one in front of that. We see this very large one, which seems to have this portion cut out of it. This does not seem to be a feature in front of it, because you can see the edge of it sort of becomes progressively darker, which indicates that actually a portion of this object seems to be cut out of it, which is very strange. So we'll call this one the missing piece stellar core. We can see this darkness along its left edge. That's the side where the sun is, and it gets progressively brighter as we move towards the right. And so again, this is due to this exchange of energy that these objects have. And even the smaller one is definitely darker on this side, the side facing the sun, than on the other side, even though it's much darker. We also see this circular outline, which indicates the presence of another stellar core behind these ones. Now, this is another image from March 26, 2008. Again, we see the dark triangle stellar core, and this dark feature on it, triangle, seems to have rotated even further to the left, again showing that this object rotates. There is the circle here, which indicates the presence of a dark stellar core as well. So there are two in this image. We also see that the object seems to be covered in plasma. These look like flowing, hot, boiling plasma on its surface, and it may even be having some type of solar flaring or CME type activity on its surface. So the dark triangle stellar core is obviously a star. A star has plasma on its surface. It ionizes its outer surface and produces this hot churning plasma that emits light and has nuclear reactions on its surface as well. So it looks a lot like a normal star. However, these objects are old stars. When they come into the solar system, they do not emit visible light. They only emit infrared light, because they had gotten to the point where their energy was so low that they could no longer emit visible light. And these are objects that have lost most of their ionizing material by going through the red giant and white dwarf phases. So when they arrive at the sun, they seem to mostly be an exposed core, or to have a thin layer of ionizing material clinging to that core, hence the name stellar core. They then proceed to shed and exchange the remaining ionizing envelope, which remains on the core of the object, with the sun. They thus obtain new ionizing material from the sun, and once they have enough energy, they start to ionize it, restart fusion reactions from the core surface, and restart the emission of light. However, the sun's core is believed to be 1/5 of the size of the sun. So a stellar core, which seems to be about the same size as the sun, would have been 5 times larger than the sun in its main sequence phase. Thus, these are old but very powerful objects, and with still very strong magnetic fields through which they connect to the sun and withdraw plasma from it, much like a white dwarf does from a main sequence star. This is well known that white dwarfs do that when they have a main sequence companion. Now here, this is from September 8, 2008, and we see 3 rejuvenated stellar cores. We see the one in the forefront, obviously, because of these rounded patches. We can see that it has plasma. It's darker again on the left, on the side where the sun is. It also has some dark patches on it, which has not been seen before. Then there's another one behind it, and again we see from the left side that it must have plasma on its surface as well, and it's bright and emitting a lot of light. And then this circular outline here indicates the presence of another stellar core, and you see that the dark patch here means that it's possibly exchanging plasma, which is coming from the stellar core, is moving towards the sun. And this indicates that these objects are still in a rejuvenation process and exchanging plasma with the sun and absorbing energy from the sun. Now in this image, we have again, this is an image which was shown above, another visible light HI1b image, where we can see the three stellar cores, a very large one, the triangle, the dark triangle stellar core, and the energetic stellar core with the large plasma ejection. And this arrangement is similar to what we see in this LASCO C2 image, where we see several stellar cores superimposed on each other. We certainly have one there. It's very clear. It's outlined. We see a smaller one. We see a smaller one in front of that. There may possibly be another one there. And then we see this dark plasma connection between these stellar cores and most likely the sun from behind the occulter. And this plasma exchange may be the same as what we see in a lot of these objects when we see the left-hand side looking so dark. So this is likely to be plasma, which does not emit a lot of light, because it's what these objects have. It's old ionizing material that they cannot use to emit light, and they are exchanging it with the sun. So the sun is getting this material, and they absorbing higher energy plasma from the sun, which they can then use to start emitting light. So now that we have analyzed these images, we are ready to analyze this image, which comes from March 21st, 2011. And this is the dark triangle stellar core, but it's obviously in the HI1A, so it's a stereo A image. So now the sun is on the right. And we can see that again we have this darker portion of the object on the side facing the sun. We see this circle which indicates the presence of a darker stellar core in the image. And the difference is that this, the dark triangle stellar core seems to have superimposed upon it an ultraviolet image of the sun upon it in order to hide the fact that it is the dark triangle stellar core. And as you can see, it seems to be a rotated image of the sun, and in later images there are some where this object seems to rotate from top to bottom, so along a horizontal axis, and or in a plane perpendicular to the ecliptic, and that is, we do know that this object rotates in a plane which is close to the ecliptic, as I have indicated before. So it seems that these ultraviolet images are being rotated and superimposed on these images in order to hide the fact that there are stellar cores in the stereo A HI1 images. Notice that it's not possible for the same detector to view the sun in visible light in ultraviolet light. There have to be two different detectors. And the sun looks very different in visible light to what it looks like in ultraviolet light, as different layers of the sun are viewed at different wavelengths. So this shows that an ultraviolet image of the sun was superimposed on the stellar core, which appeared in the image in order to hide its presence in the sun's outer corona. Now, the fact that very large are visible in just about every HI1 image until recently indicates that these objects are staying very close to the sun and close to its equator, as indicated in the LASCO C2 image shown above, and these objects must therefore be very large. And the fact that the sun appears to be about the same size as the stellar cores, and we can see in this image, this is of course taken by the same spacecraft, Stereo A, so it is at the same distance from the sun basically that it is from the stellar core, which must be just to the left of the sun. The sun would have been here. So this indicates, when we compare the two images, that this object is about the same size as the sun. And then the very large, the L1 stellar core, or the one that had the missing piece, would have been about 1.5 to twice the size of the sun. And these are objects that have therefore been there for quite a while, since at least 2008. They are visible in the 2007 images as well. So I just haven't shown them here. Now, in conclusion, 5 or 6 very large stellar cores have been observed in the sun's outer corona since at least 2008. These objects are clearly present in the HI-1b images shown above, and the objects continue to appear from time to time in the HI-1a, which are visible light images. However, their presence is being hidden through various techniques, including superimposing EUVI, or ultraviolet images, on the sun on the images of the stellar cores. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching. Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled "The Planet X System is Here," and it is huge. Now, there's a lot of evidence suggesting that Planet X, which was discovered by Dr. Robert Harrington, is now in the inner solar system, and I have written several articles about this. And also that it's affecting our planet in several ways. Now, this brown dwarf star contains many thousands of objects in it. It's not just one brown dwarf star. And it is possible that it's not actually the only system that has converged on the sun at this time. Now, the dead star, which nowadays I call Nemesis, which was found in the constellation Orion in 1983, was coming in towards the sun then. And the fact that both Planet X and Nemesis converged on the sun at the same time, which is now, this suggests that possibly they are part of the same system, which would make this system extremely large. Now, the ancient records talk of objects coming into the solar system and causing cataclysmic events on Earth, and even talk about the creation of the asteroid belt. But none of these records speak of the huge numbers of stars that we now have around our sun. It is possible, though, that they were not able to observe them all, as they did not have the instruments we have now, and that they thought that whichever object was visible was a planet, never realizing they were actually stars. However, I find this unlikely because we now have such huge numbers of stellar cores. These are brown dwarf stars. I like to call them stellar cores, and you will see why as we move further into the article. And these have been here since at least the 1990s, and we have evidence of that. I'm going to show you some of that evidence. Now, these objects have close orbits around our sun, or actually clustered in its corona, and therefore it does not seem likely that they will ever leave. They show signs of using the sun as a source of fuel, as a host, and they have attached themselves to the sun. Some of them have rejuvenated, some are still rejuvenating, that is, they start to be able to emit light, but they are here in unbelievable numbers. So we start here with this image. This is from 1996. It's a LASCO C1 image. It's one of the coronagraphs that was part of the SOHO satellite and the LASCO instruments, and it stopped working a few years ago, and but from it we could see the closest to the surface of the sun. Now, so this is an old image from August 6, 1996, and we could see already that there were several objects in the sun's corona. I think I moved this image because the circle's supposed to be there. So this is supposed to highlight that object there. There is an object here, there's another object there, and what these objects look like is a dark circular pattern, and then a cloud-like structure around it that is ring-shaped or close to ring-shaped. And if you look at these, they donut-shaped actually, and there's a hole in the donut, and through the hole you can see the core of the object, which is dark inside it. So there were several of these already there in 1996. This is an image from 2001. This is from the Yoko satellite, the Japanese satellite. And this is one of the images. This is, I think, its last image that it sent back to Earth. And as you can see, there's a large object in front of the sun. And this object, if you look at it, this is an X-ray image. So this object is not emitting a lot of X-rays, but it's not black. If it didn't emit any X-rays at all, it would be black. This object emits some X-rays. And you see that the surface seems to have all these dots on it, which are associated with the surface of a star. This bubbling of plasma produces this kind of pattern on the surface of stars. We also see that there were small stellar cores close to the surface of the sun. We can see several of them. There's one there, there's several there. And so they were there in 2001, and there was this large object in the inner solar system. We don't know how close it was to the sun. If it was close to the sun, it would have been at least the size of the sun. And the previous image before that one is this one, where you can see the object is actually moving in across the sun, and we can see the path that it's taking. So this is close to a polar orbit. There seems to be another one there, and it seems to be partially covered in a plasma from the sun, maybe even interacting with the sun. I cannot be sure, but this looks like it could be an interaction. So if this object is at the sun, as you can see, it's enormous. And if this object is close to the sun as well, of course it could be close to the camera, but if it is close to the sun, and look at it, look at its surface, it's similar to the sun's surface. This has to be a star. You can see that the pattern there is similar to what we see here. So we again see there are several of these objects. You see that little dot with a circular cloud-like structure around it. That's indicative of these objects being there already. Now these are ultraviolet image, extreme ultraviolet in 195 angstrom, and this is a stereo A image and from 2017. And when we look closely at the corona on the right hand side, we see these objects, and again we see the structure of the dot and the cloud around it, but these seem to be at regular patterns around one bright circle. And what it looks like is that there are 4 very small stellar cores that have attached themselves to a central one, and the central one is able to emit bright light, bright ultraviolet light. These ones are still in the process of rejuvenating because they have dark cores. There is some light coming from what I call the ionizing envelope, which is toroidal in shape. And we see some more of these images. Also from August 2017, we see that this is one of these objects. You can see it's dark, and there's a plasma connection between the object and either another one of these objects in the sun's corona or the sun itself. And then there is another one of these objects. This one has a bright center. It seems to be emitting light from there. And there are possibly others clustered around it. Now, these stars connect magnetically to the sun, and they draw plasma from the sun through this magnetic connection. I've talked about this many times. They don't seem to act in a way that you would expect, gravitationally speaking. So I've started using rather the electric force as a way of explaining, and the magnetic force a way of explaining what is actually happening between these objects and the sun. The objects seem to have large magnetic fields because we sometimes see very large plasma loops coming from them. So, and we would expect a magnetic connection to create a magnetic flux transfer, which we also observe between these objects and the sun. Now, this is the blue-brown dwarf that was captured by Scott Sion in May of 2017 with his telescope, and he photographed it. So this is a stellar core. In other images, like this one here, this came from an astronomer in Germany. You can see that the core of the object is solid because it has grooves in it, and it has this material attached to it, which it obviously ionizes, turns it into the gaseous plasma, and exchanges with other stars. We believe this star here is the sun. There is this pink magenta gaseous plasma around which this object seems to be gathering on its surface, and this is what they do. They form these plasma connections between main sequence stars like the sun and themselves, and they eventually gather enough plasma and energy. They gather energy by absorbing light, and eventually they are able to ionize the plasma that they have gathered and start producing light. And I call that rejuvenation. And I've always thought that this was the sun, but now with the new images, I'm not sure that all of these objects that we see here are the sun. There seems to be a huge white star with a huge magenta star, and this coronal gas plasma may be coming from that other star. They're all very close to the sun, and often are seen aligned with it. Now, we do know that we have to have a star that emits this color in order to get our atmosphere to look like this. You can see even here on the cars that the light that they are reflecting is magenta colored. And this cannot come from our sun unless something drastic has happened to it. This is likely to come from another star that has invaded our solar system, possibly part of the Planet X system that has come in, possibly came in as a dark stellar core, and it then rejuvenated and started emitting this type of light. And here we see the sky. It looks orange. Again, the sun does not emit this light. This has to come from another star. And this comes from Neil Oakley. This image, this one was taken by Scott. And this is another Neil Oakley image, which I saw in Prep Aussie's recent video. And I had a lot to say and think regarding this image, because if you look at it, it looks like a white star, but then the edge is sort of pinky colored, and then there's yellow around that. There's a bright star here. It's very small compared with this. There seems to be another one there, bright and orangey colored. The sky is orangey and pink, and these are not natural colors for planet Earth. It must come from stars emitting other lights. And this is one of perhaps testing images based on this one. And you can see that the brightest object is definitely this, because whatever bright object would look darker in this inverse image. And he did point out a lot of the objects that seem to be aligned on the sides of these. These are, of course, the smaller stellar cores with they have dark centers and ring-like envelopes. So I took this image, and after thinking about it, I came up with this. I thought, this is what we are likely to have. A large white star, a large pink star behind it, and a large yellow star behind it. And it could be the yellow star is the sun, because the sun is supposed to look yellow in our atmosphere, because it actually emits white light, but the blue is scattered out of the white light, so it would look yellow inside the Earth's atmosphere. But we cannot be sure that it is the sun. This could be the sun. It's difficult to see the correct perspective. So this seems to be the brightest star, so it could be the sun. But I see all these objects aligned with these stars. So I started thinking that possibly that's the sun, because we usually see these stars around our sun. So this would be the side view. We'd have the white, let's go back there. We have the white, the pink, the yellow, and possibly the sun, with these smaller ones aligned around it, because these stars seem to have congregated around the sun, because the sun is the source of the energy. The sun is the bright, living main sequence star. These objects were most probably dead when they arrived in the solar system. They absorbed energy and plasma from the sun until they were able to rejuvenate. And so there are these smaller ones, the orange star, the brightly star. This could be the sun, or this could be the sun. I cannot be completely sure. I think it's more likely that the sun is aligned with the rest of these stars, but I cannot be completely sure. And this would be what the ecliptic view from Earth would be. We'd have to turn it on its side. So this now is the north of the ecliptic. This is the south of the ecliptic. If this is the sun, these stars are on the side, and then all of these smaller stellar cores are aligned with them in this way. And if we then look at the motion that these objects seem to have, it seems to be close to a polar orbit. So if we have the sun here, they would move more or less like this, but I've tilted it a little bit because it's not completely polar. And then there's orbital precession. So this would explain why the objects are sometimes seen on the ecliptic, which means when this object is here, we'd be able to see it next to the sun. Or if it's back there, we'd be able to see it there next to the sun on the left. And they are then able, because the orbit precesses, and they are so close to the sun, they must orbit extremely fast. They are able to appear in front of the sun when the orbit precesses to the point that it passes in front of the sun. But these are not the only objects. I've only placed the pink or the magenta colored one and the white one together and aligned here. But we do have others. We have the blue-brown dwarf that was originally observed about this position, slightly behind the sun. It possibly has an orbital, an orbit like this, polar type orbit, inclined to one side. But we do have objects that seem to follow the ecliptic as well. There was one found recently about the same size as Jupiter that Scott found. And so I've drawn it in because we have large numbers of these objects. These are the larger ones that we've observed close to the sun. Some of them seem to actually stay stationary. At least they seem to when they first arrive at the sun, and they're still dark because we see them being illuminated by the CMEs. And we have some images of those. We see one here. You can see how large this object is. It's at least the size of the sun. Here's a close-up of it. You can see it's a dark stellar core, not emitting light. We see that the CME is directed towards it, and it makes its presence obvious. Then there was this one. This one was from July 23rd. There was a large CME. These objects seem to provoke the sun into having large CMEs because, of course, it's understandable because these objects have high magnetic fields. They pull on the sun's magnetic field. And when you pull on the sun's magnetic field, then the sun is not able to hold on to its plasma. And actually, we get the sort of huge reaction, a huge explosive reaction of the sun, which is actually very dangerous for Earth if it is Earth directed. In other words, if this object was in front of the sun and the CME was in that direction, the Earth would be in the line of fire, and this would be dangerous for us. Now, some of these are extremely large. As you can see, this one is at least 3 times the size of the sun. And it's not alone. There are several of these smaller stellar cores in front of it and seem to possibly be attached to it. There's some there, there's some there. They are actually everywhere. There are some here. And this here actually seems to be an object itself. And this object seems to have made a permanent connection with the sun, a very strong particle flux transfer connection between the sun and this object. And it has been there for years. I've been looking at this for years. This object seems to have a powerful reaction. It seems to be emitting a lot of material that comes out in this direction. And possibly a lot of the smaller stellar cores are in that stream and possibly taking advantage of the plasma that streams out in this direction, or they are maybe attracted to them. So, in conclusion, the Planet X system seems to have arrived and possibly been here for a long time. But it has not come alone. It seems to have brought a system with innumerable objects in it. This system seems to be made of old or dead stars, which we call brown dwarf stars or stellar cores. These objects are not likely to ever leave, but they are destabilizing our sun, and that poses great risk for Earth in the form of huge solar flares and CMEs. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.
I used to be a senior software engineer at Google until they fired.
Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to talk to you about another one of my articles. This one's entitled Planet X Earthquakes, Strange Tidal Events and Stellar Cores. Now, I have written extensively on how the Planet X system has brought in with it brown dwarf stars or stellar cores. And these objects are likely to have a disruptive effect on the sun and the Earth. Now, a map showing the number of earthquakes worldwide in the last 24 hours from October 9, 2017 at 1:10 UTC appears in Figure 1 below. The map is provided by the European Mediterranean Seismology Office and does not show every actual magnitude 4 and above earthquake that has occurred in the last 24 hours, but it does give an idea of the current seismic activity occurring on the planet. And we do have 4 earthquakes with a magnitude of 6 and above in the last 24 hours. And this indicates a high level of earthquake activity. So it's a good way to, I think it's a good idea to look into it to see what might possibly be causing this. So the sun does have very large coronal holes at the moment, and these are Earth-facing coronal holes. And so we will have fast solar wind and cosmic radiation coming from these coronal holes. And that means the Earth is probably being impacted by large amounts of cosmic radiation right now. But now, as I've written before, earthquakes are electrical in nature, and so it's also possible that an object with a very high magnetic field has approached the Earth and is inducing currents in the Earth, which is leading to this increased earthquake activity. And here in these images we see the coronal holes. This is a gauss image, so it's in X-rays, and we can definitely see this huge coronal hole facing the Earth. And here we see a large one up here, but we see the sun's surface also opening up, or the corona opening up, so that we can see below it. And because there's all this darkness here, so these are smaller coronal holes, but they are covering a large portion of the surface of the sun. Now the fact that the ocean again receded from the Brazilian coast, and we can see it here in a photograph from October 7th, 2017. This is an empty beach in Brazil, so it's happening once again. This started happening in August, it seems, and it continues to happen. And this is, as I've explained before, possibly due to the Earth wobbling. And this wobbling would be because there's a shift in the Earth's magnetic poles. And this would indicate a magnetic influence on the Earth. Now we do know that there are large numbers of stellar cores in the sun's corona, and we can see these in some of these images below. And these are the smaller ones here. There's definitely one there, there's another one there, there's one there, and there are large amounts of these smaller stellar cores in the sun's corona. They absorb plasma from the sun. Stellar cores are old stars, and they've therefore gone through an aging process. They must have gone through the red giant and the white dwarf phases. They lost most of their outer layers of ionizing material, and in the end they end up with the core of the star exposed and basically only emitting infrared light. So they will appear to be dark unless they are viewed through an infrared telescope. Now these objects also absorb energy from the sun in the form of light and absorb plasma from the sun, and eventually after a while in the sun's corona they are able to once again emit light. And then they seem to move into an orbit around the sun, a close orbit, but probably not as close as they were in the sun's corona during the rejuvenation process. So it's possible that at times, as they move in their trajectories, that they come closer to the Earth than at other times, and so have a stronger influence on the Earth and possibly cause certain disruptions and wobbling of the Earth's poles. And it's also possible that there may be an object that is still moving into a stable orbit and is approaching the Earth a bit more than it has before. But there does seem to be some kind of influence on the Earth that is causing these tidal events and these earthquakes. Now this is an image from Prep Aussie that he sent me. And in this image, this is from an image from 2014, and he tests these images and he can see the objects in the sun's corona. This image, as you can see, there are these white lines. These are basically bolts, discharge bolts between the sun and these objects that are close to it. And here we can see the circular outline here, there's a discontinuity between the edge. You can clearly see that. This is actually an object in front of the sun, and it's covered in plasma, just like the sun. So it's absorbed, most probably, this plasma from the sun. And I think there are others that Prep Aussie saw. Oh yes, there's this plasma coming up from the sun, and there seems to be an object there. So this plasma is connecting to this object. And here we see another plasma connection that seems to be made. Is possibly an object up here somewhere that is connecting to the sun and drawing plasma from the sun, in exactly the same way that white dwarf stars draw plasma from main sequence stars. So this is one of the ways that I saw that these objects must have become white dwarfs and then cooled down to become these stellar cores or brown dwarf stars. And this is one found by Scott, and this image is from October 4th, 2007. It's a composite SDO image, and you can see the clear, perfect circular outline of an object there to the right of the sun. And this object would have been at least the size of Jupiter, possibly larger. It does seem to be slightly behind the sun, but these objects are usually very close to the sun and typically in the sun's corona and absorbing energy and plasma from the sun from there. Now, as I have explained before, stellar cores have very dense solid cores and have ionizing material which seems to be in the solid phase. And we can see that in one of the which I'll show just now.
Hello, Charles Dickens. Any chance of a new book soon?
Just when he thought he was out of ideas.
My lamp's gone out.
One of the images, which I'll show just now. But this material can be turned into gas by the star for some reason. So it has ionizing materials in the solid phase. I believe that's in a dusty plasma or complex plasma form. And a complex plasma is basically plasma, just ionized particles. It could be protons and electrons. And then added to it are larger particles called microparticles or dust. And these are suspended in the plasma. And that leads to the plasma being able to exist in the solid and liquid phases. And the material on the blue stellar core looked like it was in a solid phase. But it is able to sort of boil this material and turn it into a gaseous plasma, which it then exchanges with the sun. Now, the ionized gas used to generate the plasma in these experiments with dusty plasma is usually argon, which is interesting since argon, when ionized, glows in a magenta color, which some of the rejuvenated stellar cores seem to emit, and thus produce the pink clouds and sunsets we often see on Earth. And here is a discharge tube with argon in it. As you can see, it glows in this pink or magenta color light. So this is the color of argon in its plasma form. And this is interesting because this would mean that we possibly have stellar cores that have at least some of their gaseous plasma may be argon. And then we have this image. We can see what the glow colors of other noble gases are. When placed in discharge tubes, we have helium here. So you can see it's quite orange, and we do sometimes see very orange clouds in the sky. So we could have helium being produced by some of these stellar cores, and the rest are neon, argon, krypton, and xenon. Now, so it's possible that these stars contain these elements in their ionizing envelopes and that they boil them off and they produce this kind of glow colors in their plasma. the coronal type plasma. Now, the solid core itself must be made of very dense material, and since they all seem to have very strong magnetic fields, these have to be superconducting, since this is the only way that a solid rotating object can produce a strong magnetic field. So the Earth's magnetic field is produced by, or it is believed to be produced by, the Earth's liquid core, which has a high concentration of iron, and iron is easy to magnetize, and it's also a good conductor. And its rotation then leads to the generation of the Earth's magnetic field. But stellar cores do not seem to have material in the liquid phase. They seem to have the solid material attached to the core, and then they have this gaseous plasma, which seems to, so basically it probably sublimates. So it goes directly from the solid to the liquid phase from the surface of the object. So these objects' magnetic field are probably produced in a manner which is, well, possibly different from the way Earth's magnetic field is produced. So the object that we see here, this is the blue stellar core. As you can see, it's solid. We can see it's solid because it has grooves in its surface, and this is its ionizing material. It doesn't have much left, so we can see the exposed stellar core. And the fact that it is very dense is obvious because it doesn't melt in the sun's corona, and the melting point goes up with density. And these objects have therefore, I believe, been formed inside a main sequence star, and then it ages and the core becomes exposed. Now, it is believed that these are produced due to the very strong gravitational attraction inside a star, and I don't believe that's the case. I believe that what has actually happened is that magnetic fields are able to compress and contain matter and produce high pressure as well. So these stellar cores are probably produced under a high compressed force, which is probably not gravitational but magnetic in origin. And we do know that stars are produced using the Z-pinch effect, which is also a compressive force. So now stellar cores are able to connect magnetically with each other and the sun and draw plasma from either sun or another rejuvenated stellar core that has gained some energy from the sun. And it does this, and we can see it here. So they gain electrical potential energy from the sun, I believe. They also draw plasma from the sun. As you can see, plasma from the sun is being drawn towards the star here. They do this through a magnetic connection. And we also see that some of this plasma that has gathered on the bottom of this object emits this pink or magenta light. Now, this is possibly because the object itself produces this plasma which emits magenta light, or it's actually getting it from another one. Even the sun here looks a little bit pink, and it may be pink because it's exchanging plasma with the stellar core or another stellar core, and this object could be gaining this plasma from another stellar core as well. But this one here is paler and seems to come directly from the sun's corona, which is here. Now, a solid conductor will generate a dipole magnetic field. That is a magnetic field that is in the shape of that of a ball magnet. And this magnetic field aligns with the axis of rotation of a conductor as long as, well, it is superconducting. So this means that stellar cores are probably made of metals or other materials that are superconducting. And a superconductor is a material that through which a flow of current will flow indefinitely, because the resistance to current flow is zero. And one way to produce superconductivity in a metal is to subject it to enormous pressures. And since stellar cores are produced under high pressure inside a star, they are able to become superconducting and therefore be able to generate such powerful magnetic fields as we know these objects must have. The sun's density, the density of the sun's core is believed to be 150 grams per centimeter cubed. So this is an extremely high density, and it would most certainly turn metals such as iron into a superconductor. However, at these densities, other materials also become superconducting, and we do have materials like, for example, lithium, beryllium, carbon, and silicon, which are superconducting at high pressures. But even if most of these objects are not made of iron, or let's say they are made of carbon or beryllium or even silicon, I believe they will have quite a large amount of metals in them. And the reason for that is the metals in a material can be used to transform light energy into electrical potential energy. And we do know from observing the 2007 stellar core that these objects seem to absorb energy from the sun in the form of light and transform it into electrical potential energy. So if we look at these images, so this is the 2007 stellar core. It approached the sun in 2007, and it was emitting light from its ionizing envelope initially, and as it got closer and closer to the sun, it became darker. It emitted less and less light until over here it looks almost completely black. And this showed me that it was going from a light emission or a light energy emission mode to an energy absorption mode. And this energy was probably, it was getting the energy from light itself. So there is probably at least some proportion of these stellar cores that have metallic materials in them. And the way that that we can have the transformation of light into electric potential energy is having a metallic conductor with metallic nanoparticles on the surface. And these nanoparticles give rise to clouds of electrons called plasmons. And these oscillate with a given frequency on the surface of the conductor. And then these plasmons actually tune their resonant frequency to the light that shines on them. And this produces a potential difference between the clouds of electrons and the surface. So the tuning is done by a flow of electrons, which is basically a current between the plasmon and the surface. And it leads to a change in the potential difference between the two, which of course is actually electrical potential energy and can add electrical potential energy to the conductor or the stellar core. So this means that these objects are able to increase the electric potential energy by absorbing light from the sun. They would then use this energy to ionize the ionizing material or plasma that they draw from the sun through a magnetic connection and exchange with the sun. In conclusion, the Planet X system seems to have brought with it large numbers of old stars or stellar cores, which have been observed in the sun's corona. It is now possible to have a better idea as well of what these objects may be made of and how they are gaining electrical potential energy through absorbing light from the sun. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.